taking the show on the road today. We're outside, you got a beautiful day. Welcome to Tuesday, your lesson. We're going to be talking about friction, and tomorrow we're talking about gravity. Today we're going to focus on friction. You all know a lot about friction. I have some help here. I have Cosmo over here to help us out. He's our demonstrator. Friction is the force between two objects. You all know this trick where you rub your hands together, and the faster you go, the hotter it gets because there's more frictional force there. Well, also, if you press down harder, that can affect the friction too. So friction is a contact between two surfaces. Two things can affect it. One being the roughness of the surface. I have some carpeting down here, and I have a smooth path of cement. We're going to have Cosmo go over there. We're going to have Cosmo try to bring the longboard on the carpet first. Probably not going to go over. He's going to push off with the same amount of force. Go ahead, Cos. It doesn't go very far. Now I'm going to try it on the nice smooth cement. And obviously we know what's going to happen. There you go. Nice. It's his brand new longboard, by the way. He got it for his birthday. Came just today. All right, the second thing, which Cosmo is going to help me with, the second thing that could affect friction is the amount of force or the strength of force between surfaces. Okay, remember I said if you push down really hard, it really burns. So if I have a plain old skim board here with not much weight to it, I can usually drag it across the pavement. That's called sliding friction, which you read about already. But if I have more downward force, in this case, causes weight, it's going to make there's going to be a lot more friction between the board and the cement. It's going to be a lot harder for me to drag it across. It'd be a lot easier if we had snow. It'll be a little more slippery, overcoming that friction. So the two things that affect friction: the roughness of the surface or smoothness of the surface, and how much force between the surfaces. More weight on something is harder to move. Okay? An empty box is a lot easier to move if you're pushing it than a box that's full. Okay? All right, we're going to talk about four types of friction. First of all, static friction, and then we'll talk about sliding friction, rolling friction, and fluid friction. So the first one is static friction. Take a look at these tires. The tire is in contact with the cement. The car is not moving, it's not sliding, it's not stationary. That's an example of static friction. Every time you take a step, okay, fortunately we have static friction, otherwise you'd be slipping and sliding all over the place. Well, you have static friction when you walk. If you're walking on ice, you might slip and slide, there's less static friction there. So the static friction, as soon as I push on this car, and if I was able to push it down the driveway, it would go from static to sliding friction. But right now there's enough static friction, fortunately, that the car doesn't go sliding down the driveway. If this driveway was covered with ice, it might not have enough static friction. It might go sliding down the driveway. When Kaz was on his longboard, there was static friction between his shoes and the board. Kept them from sliding around. In fact, here's a nice rough surface. I don't know if you can see this on the board. He's got some grip tape on there. That's a rough surface so he doesn't stick, so he has static friction when he's longboarding. When we put Kaz back to work, he's going to head up the hill. We're talking about rolling friction in a second. Rolling friction, when an object is rolling across the surface. Okay? That's good right there. Kaz, hit it. Can you see it from there? Mm-hmm. Kaz, right there's good. So obviously the wheels make a big difference. The ball bearings inside there, come on over here. The ball bearings inside there make a big difference. You can lubricate it, make it roll faster, easier. If we go over here to my bikes, the type of wheels make a difference too. This one is going to have not very much rolling resistance. Very skinny, thin, high pressure tire. It's a road bike. So it's going to go a lot faster. It's going to roll a lot easier. It's able to overcome that friction easier. This one's not made to go really fast. It's made to grip the dirt. So it's a wider tire. More surface area in contact with the ground, so it's not going to roll as easy. Okay. All right. Sliding friction. Guys, let's see your snowboard here. I know we have a lot of snowboarders and skiers in the district, so we're all familiar with waxing your snowboard to overcome sliding friction to make it go faster. Skis, snowboards, bobsleds. We're going to do an activity that you're going to be doing involving Olympic sports. So skiing, snowboarding, and bobsledding are all good ones, good examples of sliding friction. And then the last one, fluid friction. Fluid can be two things, a liquid or a gas, air or water, okay? There is friction when you're traveling through the air. There's friction when you're traveling through the water. So if you're traveling through the air, like these cars, here, have a shot over here. Let's take a look at the front end of these two cars. Can you see them both? Which one is more aerodynamic, Kaz?
Well, that one, not
The car or the Jeep?
The car.
Yeah, more curved front end, slanted windshield. On the Jeep is more squared off, so the air's going to hit it and not flow over it as easy. More straight up and down windshield as well. So this one's going to be more aerodynamic. So is this aero. This aero is very aerodynamic. Like airplanes, race cars, things like that are more aerodynamic. Something that happens when you're traveling through air as well, if you've ever been in a car and put your hand out the window, if you're doing 30 miles an hour, you ever done that, guys? 30 miles an hour, it blows back. What happens when you're doing 50 miles an hour? It goes way back, right? You really feel it. So the faster you go, the more fluid friction increases. And that's going to come into play when we talk about things like skydivers jumping out of an airplane. We're going to have Kaz jump out of an airplane with the chute. We'll give you a parachute. And the faster he drops, the more fluid friction pushing up against him will become, the more fluid friction. So friction increases with speed. The last thing is, remember I said there's liquids and gas. Can you get a shot from the front? Thank you. Allie's our camera person back there behind the scenes. Remember we said fluid friction can be a liquid or a gas, can be air or water. Well, these two kayaks traveling through the water, guys, which boat is going to travel through the water faster?
That one.
The blue one. Why?
Yeah.
Why?
It's more thinner and aerodynamic.
Okay, thinner, but it's not aerodynamic. In water, we call it hydrodynamic because hydro means water. So this one's thinner. It's more aero-like. It's going to knife through the water a lot faster. Boats are designed this way. Torpedoes, submarines, all things are more hydrodynamic. Okay, so there's your lesson on friction. I know you know a lot about friction already. Depends on type of surface and how much weight is on it. 4 types of friction. You've got static friction, something that's not moving, like this Jeep. There's static friction between the tire and the cement. Rolling friction, like the bicycle tires and the longboard tires. Sliding friction, like on skis or snowboards. And then finally, fluid friction, something traveling through the air, like these cars, or something traveling through the water, like a boat. Okay. And then tomorrow we'll be talking about gravity. I don't have my bowling ball here with me. I left it at school, so I can't drop a bowling ball off the roof to demonstrate that gravity still works, but I need something else to drop off the roof. Kaz, would you be interested?
Yeah.
All right. Tune in tomorrow to see Kaz fly or not. All right, that's it. Thank you.